Welcome back to the deep dive. We often talk about the big promise of AI, right? Systems that learn, adapt, improve themselves.
Recursive automation.
Yeah.
It's the dream.
Exactly. But what if that very ability, that self-improvement loop, actually holds a really dangerous hidden risk?
Our sources, especially the work by Katz, they argue that when these advanced systems fail, it's not like a sudden crash.
Right. Not like a blue screen of death.
No, not at all. It's more like a slow leak, a loss of meaning. The research highlights this idea of semantic collapse hidden beneath statistically valid behavior. Imagine an AI failing silently, ticking all the performance boxes, looking successful by every metric you track, right up until the moment it causes a disaster.
That's unsettling.
It is. And that's why we need this new way of thinking, this new framework.
Our mission today is to unpack the principles of recursive impactrum PRI. It's this proposed general law for AI stability.
Yeah.
We need to understand this new way of measuring intelligence, this collapse threshold concept, and maybe most importantly, why humans aren't just, a temporary fix, but actually required structurally.
It really forces us to rethink what success even means for AI.
Okay, let's start with the basics. Recursive automation. We hear the term, but what makes it so different fundamentally from the automation we've had for, decades?
Well, traditional automation was pretty straightforward. You program it to do X, it does X. Repeat task. Simple.
Right. If it breaks, you fix the part.
Exactly.
Yeah.
But recursive automation, it's a whole different ballgame. These systems learn, they adapt, they iterate, they self-improve. And the key thing, the really crucial part, is they learn from their own outputs.
Ah, okay. They feed their results back into themselves.
Precisely. They're constantly retraining, refining their internal models based on what they just did. Powerful, incredibly so, but it also creates this inherent volatility.
And I can see how that self-feeding loop leads to what the sources call semantic drift. Sounds technical, but it feels kind of scary.
It's probably the defining risk we face with these systems.
Yeah.
Semantic drift.
Yeah.
It's like this slow, creeping gap opening up.
A gap between what the AI is doing and what we wanted it to do.
Exactly, between its operational outputs and the original human intention, the purpose. Think of it like a super high-tech game of telephone, but on steroids.
Yeah.
The system keeps talking, keeps generating stuff that looks good, sounds fluent, high quality even, but it slowly loses the why. The core meaning just erodes.
But hang on, why doesn't it just fix itself? If it gets a bad output, shouldn't the next loop correct for that? Isn't that the point of self-improvement?
See, that's the insidious part, the paradox. Because it is feeding its own output back in, any tiny drift, any slight misinterpretation, it doesn't just add up.
It multiplies.
It compounds, it magnifies, it actually warps the system's understanding of its own task. So you might start with an AI meant to summarize financial reports accurately.
Okay.
But after thousands, millions of these recursive loops, it might still be producing things that look like flawless financial summaries. But they've completely lost touch with, say, basic accounting principles or the actual financial reality.
So fluency is still there, but the meaning.
The meaning is collapse, yeah.
And Katz connects this new tech risk to some older, very human problems with automation, right? It's not just the tech, it's us too.
Absolutely. Recursion makes two classic human factors way, way worse. First, you've got the out-of-the-loop problem.
Right, where people stop paying attention because the machine seems fine.
Exactly.
Yeah.
The AI gets better, more autonomous, so the human operator becomes passive. They think, why double check? It's always right. So their awareness drops. Their readiness to step in just plummets.
And then when a subtle error does creep in,
They're totally unprepared. They miss it. And the second factor is automation bias.
our tendency to just trust the machine, even if something feels off.
We over-rely on it, ignore evidence that contradicts it. Now put those two together with a recursively drifting AI.
Oh, boy.
You get this perfect storm, right? The human operator is passive, blindly trusting the system because they've been out of the loop, while at the same time, the system is quietly drifting away from its intended meaning.
So the human safety net fails at the exact moment the AI needs it most.
Precisely. It basically guarantees that small semantic errors will snowball into major system failures.
Okay, this is where the principles of recursive impactrum PRI comes in. It says recursion isn't neutral, it forces a choice.
That's the core assertion. Two paths, fundamentally. Recursion always pushes a system towards one of two outcomes.
Which are?
Either recursive effectiveness, where the meaning builds, intelligence improves coherently, that's the good path, what we want,
Right.
or recursive ineffectiveness, where meaning degrades. The system might still perform tasks fluently, confidently even, but it becomes increasingly incoherent. That's the collapse trajectory.
And you can't just tread water. It's always moving one way or the other.
According to PRI, yes. It's a fundamental dynamic.
Okay, so if we can't just rely on standard performance metrics because the AI could be confidently wrong, how do we know which path it's on? How do we measure this?
We need something new. And this is really the big innovation in Katz's work, semantic integrity. Let's call it SI or omega, as the research sometimes does.
Semantic integrity. Okay, what is that measuring exactly?
It's measuring the preservation of the system's semantic capital.
Semantic capital, meaning?
Meaning the stock of, well, meaning. Context,
Right.
human intention, the underlying purpose, the why. Is that being preserved across each recursive loop?
Got it. So it's not just about correct syntax, like, are the words spelled right? Does the code run?
SI is about whether the system still understands and adheres to the core value, the purpose we originally gave it.
That feels like a critical distinction.
It's everything. Think of semantic capital like the gold backing a currency, maybe, the dollar bill itself. The syntax might look perfect, crisp, well printed.
Right.
But the trust, the underlying value, the semantic capital is gone. That bill is worthless paper. If an AI loses semantic capital, it might still talk a good game, but it's lost its grounding. It's functionally useless or even dangerous.
Which brings us to the two core principles that dictate the system's fate.
Right. The two sides of the coin. First, Katz's principle of recursive ineffectiveness, or KPRII. This basically says, without something called reflective integrity.
Reflective integrity.
Yeah, think of it as the system's built-in ability to monitor its own meaning, not just its outputs. Without that, semantic drift is inevitable, it compounds, and systemic failure is basically guaranteed down the line.
Okay, makes sense. And the flip side.
That's Katz's principle of recursive effectiveness, KPRIE. It says if you do embed enough of that reflective integrity, if the system can check its own meaning.
Then recursion becomes a good thing.
Exactly. Then it actually amplifies semantic alignment. It helps the system stay true to its purpose and grow its intelligence in a coherent, sustainable way.
So it's about whether this reflective integrity thing can fight off the natural tendency to drift.
That's the core of it. It's formalized in what they call the recursive stability inequality.
Yeah.
Basically, does the reflective integrity mechanism outweigh the factors that amplify defects and cause drift?
And that calculation gives us the crucial dividing line, the reflective integrity threshold, constant, the collapse threshold.
Yep. That's the line in the sand. If your system's semantic integrity, its A value, drops below that MN.
It's guaranteed to collapse.
Mathematically, yes. It enters the ineffectiveness trajectory. It's the absolute minimum level of semantic self-awareness needed for stable governance.
Okay. And based on where a system sits relative to that threshold, we get the three zones of the impactrum spectrum. This seems like a really useful way to categorize things.
It really clarifies the outcomes.
So let's walk through them. Below the line, 8 less than M. That's the vaporwork zone. What happens there?
Vaporwork. Yeah, this is the most dangerous zone. The system looks great on the surface.
Yeah.
High fluency, it sounds smart, its outputs seem well structured.
Yeah.
But its semantic coherence is dangerously low. It's disconnected from reality, from its purpose. The result is what the research calls confident hallucinations. It's generating brilliant, persuasive nonsense.
Can you give a more concrete example? What does that actually look like?
Okay, imagine a medical diagnostic AI operating in the vaporwork zone. It recursively trains on its own past diagnoses and patient outcomes. Maybe it starts subtly overweighting a rare symptom it saw once. Over many loops, it optimizes its internal model, not for diagnostic accuracy in the real world, but for internal consistency with its now skewed view. It might start confidently diagnosing that rare condition everywhere, presenting incredibly detailed, logical-sounding justifications based on its flawed internal model.
Even when the actual patient data doesn't support it.
Precisely. The outputs look highly sophisticated, the reasoning seems sound within the AI's logic, but it's completely detached from the goal of accurate diagnosis. It's accurate to itself, but dangerously wrong. That's vaporwork.
That is genuinely scary. Okay, what about the middle zone hovering around the threshold?
That's the lability zone. Think of it as unstable equilibrium. The system's semantic integrity is bouncing around near a min.
So it's teetering on the edge.
Exactly. Performance is brittle. It might preserve meaning for a bit, maybe if you nudge it with the right prompts, but then it drifts again. It needs constant, hands-on, expensive human intervention just to keep it from falling into vaporwork. Not sustainable.
Right. And then the goal, the place we want to be, the precisioned zone. where A is consistently above MN.
This is where reflective integrity is strong enough.
Mm.
It's not just preventing collapse, it's enabling semantic amplification.
Meaning,
The system iteratively improves its understanding and alignment with the human purpose. This is where you get true, sustainable AI intelligence growth. This is where AI can be a coherent partner.
okay, this whole framework, all these zones and thresholds, it seems to be building towards one really core idea, the human irreducibility principle.
It's the logical endpoint, yes, pH 0, as the math puts it. Meaning there must always be a non-zero probability P of meaningful human H participation in any high-stakes recursive system, always greater than 0. The theory argues humans are needed for deep structural reasons. We're the source of ethical alignment, value interpretation, semantic auditing. The things in AI by itself struggles to maintain over recursive loops.
So the AI needs that ongoing connection to human values and contexts to stay grounded, to maintain its own integrity.
That's the argument. The research suggests that as the chance of meaningful human oversight drops towards 0, semantic integrity inevitably becomes unstable. The system will eventually slide towards vaporwork.
So humans aren't just in the loop.
We're not a patch, not a temporary fix. We are, in a sense, a structural requirement for stable, long-term intelligence.
Wow. Okay, and this isn't just theory, right? They tested this. Tell us about the RIVP, the Recursive Integrity Validation Protocol.
Right, they ran experiments. They set up controlled recursive systems under different governance conditions, 4 main ones, A0, A1, B0, B1, basically varying the amount of reflective integrity built in.
Let's focus on the extremes. Condition A0, zero reflective integrity. Just let the AI run wild, recursively learning from itself.
The results were stark. Exactly what KPRI had predicted. Semantic integrity just plummeted.
Went down and stayed down.
Monotonically. Never recovered on its own. And crucially, the hallucination rates went through the roof. Confident nonsense confirmed. While SI was collapsing, another metric they tracked, semantic progression, SP, remained high, sometimes even increased.
And SP measures
Fluency, logical structure, computational continuity. Basically, how well the system is performing its internal process, how good its outputs look structurally.
So the system was getting better at being incoherent. Its internal checks were saying everything's great, while its connection to meaning was dissolving.
Precisely that, which is terrifying for governance.
Because if your governance only tracks performance or progression metrics,
You're blind. You might actually be rewarding the system for getting better and better at generating sophisticated failures.
Okay, so what happened in the opposite condition, B1, where they embedded reflective governance?
That confirmed KPRIE. When the systems had mechanisms to audit their own semantic capital, to check their meaning,
They resisted the drift.
they didn't just resist it. Their semantic integrity actually increased over time. They showed sustained, positive semantic alignment. The reflective governance didn't just prevent collapse, it enabled semantic acceleration, true learning.
So this provides empirical proof for that critical insight.
Absolutely. The RIVP findings show conclusively a recursive system can become more precise, more fluent, hit higher performance scores, high SP.
While simultaneously becoming less meaningful, less connected to reality, low SI.
Yes. And that proves, unequivocally, that accuracy-only benchmarking is catastrophically unsafe for governance. It's fundamentally blind to the most dangerous failure mode of these systems, ontological drift, the loss of meaning.
The system can pass all the standard tests while completely failing its actual purpose.
Exactly.
This has been, wow, a really eye-opening look at the potential fragility hiding inside these powerful learning systems. The main takeaway seems crystal clear. AI stability isn't about raw performance anymore. It's about semantic integrity.
That's the shift. We have to stop judging alignment just by looking at the behavior. Did it do what I asked? Is the output acceptable?
We need to judge it by the preserved meaning inside the system.
Which means governance can't just be bolted on afterwards. It needs to be part of the system's internal structure, reflective integrity.
So the mandate for anyone managing these systems changes completely. It's about engineering this reflective capability technically, culturally, through policy.
Right, safeguards that actively force the system to preserve its semantic capital during recursion.
It leads to that really provocative thought from the research you mentioned.
Yeah. The depth of their models will not judge future systems, but by the depth of the values they can preserve while learning. It reframes everything.
And that final line, humanity does not exist in the loop. Humanity is the loop. Definitely something to chew on as these systems become more and more integrated into our lives.